Okay, so now that we have understood the part of approximations, now I would like to take you to the idea of fraction percentage conversions. Okay, they are not very difficult. First of all, I think percentage conversion is something that is taught to you in the very first class of quants. So basically, I just want you to pay attention to what I am doing and try to reciprocate that while you are practicing on your own. You can take your own numbers, or you can basically use our modules that we have provided. Let's start. The first thing is 1 by 1, we know it is 100%. 1 by 2 is 50%. 1 by 3 is 33.3333%. 1 by 4 is 25%. 1 by 5 is 20%. 1 by 6, hold on, for those of you who have a problem with 1 by 6, just look at this number. If you multiply half to 1 by 3, this becomes 1 by 6. So multiply a half to 33.33, or in other words, what is the half of 33.33? That is going to be 16.66666, or maybe 16.67, rounded off to 2 decimal places. 1 by 7 is something that you should remember, that is 14.28%. 1 by 8 is something everybody should know, but this is, I mean, if you have a problem, you can also check out this number, which is 1 by 4, 25%, half of that, 12.5%. Okay. 1 by 9 is 11.11%, is something that everybody should know. This is, you should memorize it like at the tip of your tongue. Now, 1 by 10 everyone knows is 10%. So this is not at all a problem. 1 by 11 is 9.09%. 1 by 12 is also not going to be a problem, because if I know 1 by 6, let's say this number, 1 by 6, which is 16.66666, 1 by 12 is just going to be half of that. 16.666 का half होगा 8.333333, or you can write 8.34 also. Both of them are accepted. The next bit numbers are 1 by 13, 1 by 14, and 1 by 13 is a prime number. So it becomes a little problematic to remember 1 by 13 for a simple reason, because this is a prime number. So let's do one thing. Let's just divide 100 by 13. So when I divide 100 by 13, what I get is 13 sevens are 91. Okay, I get a 9 over there. Then I put a decimal 0. 13 6 are 78, and 13 sevens are 91, so I can't put 6. So this is 2 and this is 112. Decimal 10, and 9s are 117. Whatever the remainder, I don't care. I'm just focusing on this number, which is 7.69%. Okay. Now let's look at 1 upon 14. That is again going to be an easy number. 1 upon 14 is nothing but, remember, 1 by 7 is 14.28, so that is 7.14%. Okay. 1 by 15, 1 by 15, please remember 1 by 5 is 20. So 20 by 3 is going to be 6 point, let's do this. 6 are 18, 2.0, 6 are 18, again 2 and 6.66666. So let's just write it like this, 6.67%. Then 1 upon 16. 1 upon 16 can be written as 1 upon 8. Whatever the value is, that is 12.5. If I multiply a half there, I'll need to calculate the half over here. So 6.25%. Okay. Upon 17, that is going to be a prime number. So 1 upon 17, if you don't remember, it's completely fine. If you do remember, also 5.88 or something of that sort. But then if you don't remember, what do I do? So I'll just multiply or divide the number by 100. So 17 के table में, if you remember, 17 5s are 85. So this is going to be, you give a decimal, there's a 0. So 17 into 8 is a 136. 9 is a 153. So you are getting a 4 and you are getting a 1. So decimal again, and you'll get 8 again, 136. Leave it at this, you will get 5.88%, right? Now, I hope you have understood the basic funda through which we are calculating. Even if I forget a number, I can get that number very easily. Now I am looking at 1 upon 18. 1 by 9 is 11.11%. Okay, 11.11%. Basically half of this thing. Half of this thing is going to be 5.55, whatever. 555 or 56. Okay, this can also be written as 589. This can also be written as 56. Okay, 56, whatever. Just doesn't matter, because at some point it will get eliminated, right? So you have to be like mindful of that part. 1 by 19 we'll have to calculate, and 1 by 20. 1 by 20 for a fact we know is 5%. So 1 by 19 is something 5 point something something. So what that something something is, we'll calculate that. And I'm showing you the division method for a simple reason. I want you to be acquainted with the division process also. If the tables of 19 and all scare you, so this is the best time to get rid of that. 19 5s are 95. You get a remainder 5. Decimal there 0. 19 2s are 38. You get a 2 over there. And yeah, this is 4. That is 12, right? Okay, whatever the remainder, 6. I don't care. The value is 5.26. percentage. Okay. So the fact of the matter is that even if I am not aware of a number, I can still manipulate my way towards the percentage equivalent. And you can pretty much see that if you practice enough and more number of times, you will actually remember most of the fraction and ratio conversions. Now, here we will be learning approximation techniques. Okay. So suppose a number is given to you in the form ABC upon XYZ, provided ABC is less than XYZ, that is, it's a proper fraction. Okay, proper fractions, you know, numerator is less than the denominator, or in other words, the fraction is less than 1. That is a proper fraction. Now, this thing, the student have this problem of either eliminating the numbers and then saying it is equal to AB upon XY, okay, or they'll eliminate two numbers and they'll say this is equivalent to A upon X, okay. Now, this is completely wrong. This method is not called approximation. This method is called, I don't know what this is called. This is called stupidity. What we instead will be doing is that we'll be employing a simple technique of mixtures to understand basically there is no idea of mixtures as such. It's just that we'll be employing the idea of equivalent ratios to understand the approximation technique. Okay. So see, please understand what I'm going to say. Suppose, you know, a number is given to you like 471 by 673. Now, although I think this is not a very good number, because 71 and 73 still are close. So you will get this number close to 2 by 3 because of these two numbers. Okay, if you see these two numbers are very close to each other. So in other words, I can actually approximate this to 400 by 600 or 500 by 700. I can do that. And then basically, I mean, this is what I'm trying to say is this is not a very good number. So let's make a very good number. Okay. So random number maybe yes, but not a very just like that kind of a number. So let's say 423 and 978, a number like this. Now, this is definitely not going to be equal to 4 by 9. Do we remember what 1 by 9 is? 1 by 9 is 11.11%. 4 by 9 should ideally be equal to 44.44%. Okay. Now, I will take out the calculator and predict the actual value. Not predict, but I will, you know, tell you the exact value. That is going to be 423 divided by 978. Okay, and if I multiply this by 100, I'll get the value in two decimal places. 43.25. This is the exact value. And my dear friends, this approximation by eliminating the two digits, if you can see, and if you can just, you know, look at the, you know, error, the margin of error is too high. It is not even a bad approximation. It's a very bad way of representing this thing. We don't want to do this. Obviously, we can get the exact value if I do the long division, but then we know long division is cumbersome. So what I would do ideally at this point is I would like to make some arrangements so that I can get at a good value. So I would like to explain to you one thing that I'll be employing, and that will, you know, make use of this ratio. So we will somehow, one way or the other, we will, you know, revolve around this thing, but we will call this the rough ratio. This rough ratio is something that I will use to manipulate the denominator. Because if, you know, let's say instead of 978, if this number were given to you like this, 423 divided by 1000, you would have said, sir, 3 0 ke piche 0.423. This is it. The calculation became very easy only when I had the denominator in the nearest century number. So I call 1000 a nearest century number, because even it were 500 and this were, let's say 400 something, I would call 500 my nearest century number. What the nearest century number does for me is that it makes my life so much more easier in terms of the calculation. Instead of 1000, you will also agree to me, the calculation would have been equally easy for 23 if I had the number like 900. I'll just ignore the zeros, I'll divide the expression 423 by 9, and dividing 423 by 9 is not a very difficult task. We all can do this very easily. So the bulk of my understanding will revolve around the idea how I can manipulate such that my rough ratio is intact. Okay, so let's take a number. Let's say I am taking a number like 473 divided by 928. So again, 4 by 9 is my rough ratio. I'll keep this thing in mind. What is it that I want to make? The denominator, I make the denominator 1000. Okay, this makes my life so much easier. So I'll add 2, that makes it the 30 and 72. So I have added 72 into this thing. So in the numerator, how much is it that I'll be adding? So in other words, I'm saying can you understand this now? In the denominator, I have added 72, which is 9 8s are 72, a multiplying factor of 8. So in the numerator, I'll be adding 32, which is exactly same. So the same multiplying factor, 4 8s are 32. So I'll be adding 32 to this number. So let's add 32 to this number. So this becomes 5, this becomes 10, 505, and 0.505. So this becomes 0.505. Now this is my approx value. Okay, this is my approx value. Let's check the actual value. Okay, that is 473 divided by 9, hold on, 928. That is 0.509. 0.509 is the exact value. Okay, 0.509. Now my dear friends, this is the exact value, and this much margin of error is acceptable because that is the third place from the decimal, this thing. Okay, right of decimal, third place to the right of decimal. I'll show the calculator to you again for your reference. Okay, now let me come back. Let me tell you one thing. What I did in this part, if you have some problem in doing that thing, and I got lucky that 72 happens to be a multiple of 9, so I got lucky. So this thing, 9 8 is 72, gave me a pretty good approximation, but this happened out of luck. It's not that by choice I designed this number. Okay, the thing is, instead of 72, if I had, now student should have a question ki sir ye to bahut luckily aapko 72 yahan pe mila. Instead of 72, if you had a 75 or a, let's say, 73, what would you have done? Now depending upon the options, okay, options of the DI caselet, if at all, I mean if you get a DI caselet in which you have the options, the point that again I'm trying to emphasize on, please pay attention at this point, please pay attention what I'm trying to emphasize on. Depending upon the options that are given to me, if the options are closer, let's say, you know, the options are given something like this, 0.50 like, and then 0.509, 0.508, 0.505. I'll tell you why I'm writing it like this, 0.506 or something like that. Okay, if options are like this, you leave the question, leave. The options should always ideally be given to you like this, 0.50, let's say 5 or 0.509, whatever, 0.608, 0.70, this thing, 0.403. They should be far apart. If they're not far apart, this is not then a question that you can do. You're not a human calculator. In a cat like a situation where you have a calculator, you can do that because the calculator is present for your let's say benefit. The thing that I was telling you, most of the cases, if the number is 75, I can still manipulate the number as 72. Okay, I can still manipulate this as 72 and maybe, you know, make some plus minus in the numerator. For example, if this is 75 and I suppose this as 72, then what it means is that I have to, this is 8 again, 32. So maybe I will add, instead of 32 in the numerator, maybe I'll add 33. Maybe I'll add 33.5. If you have to approximate a rough approximation of this thing, I have already told you that 9 into 5 is 45. That is something that you can do. Let's say 473 by 928 is equals to something. So something into 928 should give you 473. 9 5s are 45. So you can actually think of it like 0. something something, 0.5 something something. Or the rough ratio should also tell you that it has to be 4 by 9. 1 by 9 is 11.11%. So that will be somewhere around 44 and a little bit more or less, depending upon, because the numerator is more, it will be more than 44%. Okay, and the denominator is comparatively less. Okay, so that's, so again, the fact of the matter is you have to practice, and you have to practice with a lot of numbers. You have to be familiar with the topic. You can, suppose you have a number like this. Okay, 481,786 divided by 581,68379. What do we do now? Is it going to be, the rough ratio going to be 4 by 5? And partly yes and partly no. If you want to make sure that the rough ratio is 4 by 5, you have to add or introduce 2 zeros into the numerator, because the numerator is a 6-digit numbers. The denominator on the other hand is a 8-digit numbers. So you have to manipulate the numerator and denominator. And upon this addition of the extra 2 zeros, you have to remember to get rid of these 2 zeros at the end of the approximation. Basically what I'm trying to say is, when you have done this part, this thing becomes irrelevant for me. Now the number is 481 by 581. The same things will happen. So 4 by 5, I want to make it the 600. So let's say how much? So 9 I add becomes 90. So 19 I'm adding. So 19. Okay, so let's say this is okay, let's do this properly. 3s are 15 because I don't want to make any error, that's why I'm doing it. 3s are 15 and this becomes 4.08. Sorry, it's not 4.08, it's 3.8, right? 0.8 gives a 40, 3.8. So 3.8, 32. Hold on. 32, 3, 12 and 3 is 15. So you will add a 15.2, that is going to be a 6 and 9 and 4.2. I think this should work. Okay, divided by, please remember my dear friends, instead of 600 we'll have to introduce the 2 zeros that we have introduced over here. So this is going to be not 100 but 10,000. So this is actually going to be 4 zeros to the left of the decimal. So this is going to be 0. Okay, you will not be able to see it now. Hold on. 0.0823. 0.0823. I want to check. Let me check for the value. So I'll write the exact value. I need the exact number. So 8481786 divided by 581683, 581683 and 79. That is 0.0082. 828. 0.00828. The exact value is 0.00828. So just see where exactly the marginal error is occurring. The marginal error is occurring at the 5th position from the right of the decimal, and that is like a very precise calculation, to be very honest. Okay, but basically what I'm telling you is that the method is perfectly fine. It's just that कि अगर आप जल्दबाजी में करोगे तो 1-2 decimal point इधर उधर हो सकता है, but that's completely fine because at the end of the day the method is sacrosanct. Okay, but because we're dealing with numbers, addition, division, multiplication, so थोड़ा सा error तो रहेगा ही, marginal error तो रहेगा ही. Having said that, this is it, that all you need to understand. Thank you. Oh yeah, and लाइक शेयर सब्सक्राइब करो अगर आप करना चाहते हो तो, ठीक है.